Hello. Okay, so for condition variables, let's do like a restaurant example. So let's say these threads are like customers in a database or something. So these are people threads or customer threads. Okay, and so you acquire the mutex. So this mutex is to protect the shared data variable. Maybe there's an int table or something. Okay. Um, uh, then while there's no available table, you will wait on the condition variable has table. So has table is a condition variable, and we if we are able to get through this, then there is a table, and we call table minus minus. Okay, and then we call unlock. And when a customer leaves, we will execute this thing. So when a customer leaves, we will signal that there is a table, and we call table plus plus. Okay, so that's the general logic. So a bad way to do this would be, so if we didn't have a condition variable here and this was just a busy waiting loop, then so let's say we have thread T1 running on this processor, then it would just keep on checking whether or not it has a table. So it just, again, this it just spins. Okay, so it just keeps checking over and over again. Whereas the con wait, when it hits the con wait, it will put itself onto there's there's another queue. So this is not this is a different queue from all the other queues. This is a queue for each separate condition variable. So each condition variable will have a waiting queue. Okay. So um so when it hits the wait, it will put itself onto the waiter queue, and then within within the wait, it actually calls unlock on the mutex. Okay, so that part is a little bit hidden. You just have to remember that while you're waiting, you should not be holding on to the mutex, right? And I will show you the implementation in a little bit. I think that helps. Okay, so yeah, so again, when we hit the wait, it puts itself onto the waiter queue. Okay. So now, if if we have other threads on the ready queue, so this is the thread ready queue, it can place itself, um, then it can start running. Okay, so T1 is not just spinning and waiting while it's waiting. Okay, so this is blocked. Then when we signal, um, so so let's say a customer leaves, then we lock the mutex to protect the table variable, and we will signal it. We'll signal has table, and what signal does is it goes to this condition variable's waiter queue. So this is like has tables waiter queue, and it will take the first thing off the waiter queue, and it will unblock it. Okay, so that means it gets placed on the uthreads ready queue. Okay, and now let's say another thread runs and it ends or something, whatever. Then when T1 finally gets to run, then so within con wait, after it wakes from the wait, it actually calls lock. Yeah, so I'll show you the code a bit later. Yeah, so it will attempt to reacquire the mutex. Okay, so notice that. So why is this a while instead of an if? Um, uh, uh, versus while. There was some time between the T1 so when it was signaled, it was unblocked. Okay, then it was placed onto the ready queue, and then at some later point in the future, it actually gets run. Okay, so between that time, some other thread could have also ran this function, and it could have saw this, and then table was equal to 1 because we got signal. Then it will then the other thread goes in and gets the table and decrements it. Okay, so that's why we need this while to recheck the condition. So when T1 wakes, it has to recheck the condition to see that no other thread has changed the um, uh, changed this table variable. Okay. So then T1, if it finally gets to go in, it will consume the table. Yeah. So yeah, that's how it works. And if so this is the scenario if T1 runs first. So what if T no, I think that's another video. So yeah, so if you signal and there's nothing on the queue, it doesn't do anything. Right. Okay, so now we'll look at the code. So this code is, I think it's, this should be pretty easy to understand, right? So we have, so in wait, we will in queue the thread self onto the conditions waiter queue, and then it calls unlock on the mutex, and then it blocks. Okay, so again, it unlocks the mutex and then it blocks. So that's what I wrote here. It unlocks the mutex and then it blocks. Is this too messy? I can't do this. Yeah. And that when it wakes from the block, it will lock the mutex again. Okay. Okay. And in signal, it will so it day queues something off the waiter queue, and if there was something off, so if the day queue was successful, so this is checking like basically if the queue was not empty, then it will unblock that day queued thread. Okay. Like pretty simple, right? And broadcast, it just loops while the queue is not empty, and it just keeps on. So it unblocks everything on the waiter queue. Yeah, this is too messy, isn't it?